Next, we're going to look at finding slope from a graph. Earlier we mentioned that there's a formula for this, and we used m equals rise over run. Now in terms of what that means, we said that the rise was the vertical change, or the change in the y values. In other words, I want to know from one point to the next on the graph, how much do you need to move up or down? Up would be positive, down would be negative. And run, we mentioned, was the change in the horizontal direction, or the x values. And that will either be right or left. Right is positive, left is negative. So what you're going to do is you're going to find 2 points on the graph, let's say possibly this one and this one, and you're going to put your pencil on one and move to the other. First by moving down 1, 2, 3 spaces. Down 3 is a rise of -3, and then you're going to move to left or right horizontally. In this case it would be right 1, right being positive. So in this question our slope ends up being -3. Our last example for slope is a little bit more difficult in that you're working backwards. You're given the slope, but you're missing a coordinate to find that slope. There are 2 ways to do this. One is with a formula and one is graphically. We'll use the formula first and then we'll use the graphing method second. So if you're going to use the formula, that is the x1, y1, x2, y2, and m formula that we're talking about from earlier. So we're going to start by taking our formula and plugging all 5 of those values into the formula. So in this question our slope was 2/3, so we're replacing the m with the 2/3. y2 is y, so we're just going to put a y there. y1 is 1, x2 is 4, x1 is -2. And then we will simplify what we can here. In the denominator on the right hand side I can simplify 4 minus -2 into 6. And then I'm trying to solve this equation for y, which means that I would need to use inverse operations. The first thing I'd like to do is eliminate this fraction, knowing that a fraction is the same thing as division, and I can multiply both sides by 6, because dividing by 6 and multiplying by 6 are going to undo each other. They're going to cancel each other out, and then I'll just have y minus 1 on the right. On the other side, when I do 2/3 times 6, I get 4, and then I'll add 1 to both sides, and I will get that y is 5. Now the other way you can do this question is graphically, and to do it graphically what you would do is you would plot the point that you know, the -2, 1, and then you would plot other points using the slope. So knowing that the slope is 2/3 and the slope is also rise over run, this means that the rise is 2 and the run is 3. Rise means up or down, it's a +2, so that means up 2. Run means right or left, it's a +3, so that means right 3. So from the point that I just plotted, I'm going to go up 2, right 3, over and over again until I run out of space, basically. So I'm going to go up 2, right 3, make a new point. Up 2, right 3, up 2, right 3, up 2, right 3, and then after that I'd be off of the graph, so I'm going to stop. Now one thing that is a little tricky is that if you were to actually do a calculation with this, another way that you could have gotten a final answer with a slope of 2/3 is you could have had -2 over -3, and that would have also equaled 2/3. The -2 over -3 would be a different rise over run. Instead of up 2, it's -2, so it'd be down 2, And instead of right 3, since it's negative, it would be left 3. So I can get a few more points on my graph going back to the negative 2, 1, and then going down to left 3, down to left 3. And then that looks like that last one would go off the graph paper there. You'll notice they're still along the same line, it's just that you're going in the other direction. So finally here, we're trying to figure out what point would be 4 comma something. So we're going to the 4 on the x-axis and figuring out where it would be on the y-axis, and we can see that that would be a 5. So another way to solve this problem graphically would look like that.